11th math students, see some more problem from exercise miscellaneous exercise chapter 10. See question number 21. A line L having equidistance from two given lines L1 and L2. So L1 and L2 are parallel lines. L is parallel to both L1 and L2 having equidistance from both. So middle line L, distance from L1 is D1 and distance from L2 is D2. So here D1 is equal to D2. You have to find the equation of line L. So line L parallel to both. So its equation, coefficient of x and y will be same, only there will be difference in c. Means directly you can write the equation of line L, 3x plus 2y plus k. Change the value of constant term c. In place of c you can write k. X and y will be same as L1 and L2. Why? Because lines are parallel. So 3x plus 2y plus k is equal to 0 is equation of line L. Okay, now here you will find the value of k. For this you can determine the coordinate of any point on this line, coordinate of any point as m point on this line. So you can put any value x from the real number, putting x 0 find y, or putting y 0 find x. You can determine any point. Means you know a line passing through the infinite point means there are many points lies on the line. So here you have to determine one point by putting x 0, y is minus k by 2. So coordinate of m you can take as 0 minus k by 2, x 0, y minus k by 2. Now here you have to find the distance of both the line L1 and L2 from this point m. So perpendicular distance, what is the formula? Distance drawn from a point to the given line. So distance from line L1, D1 distance, putting the coordinate of m in L1 in place of xy. So after putting you get within mod k plus 7 by 3 root of a square plus b square means 9 plus 4, that is 13, root 13. Now draw the distance from point m on L2 by same formula. Formula you know, ax1 plus by1 plus c upon root of a square plus b square. Means putting the coordinate of m in equation L2 and dividing by root of a square plus b square. So on L2 the d2 distance is minus k plus 6 upon root 30. After putting the coordinate and dividing by a square plus b square. A means 3, its square is 9, b 4, its square is 4, so minus k plus 6 by root 30. So here d1 is equal to d2, apply d1 is equal to d2, solving it. When you remove the mod, remember here you will write in plus minus. Why? Because unknown quantity may be on the right side of 0 or on the left side of 0, so you will mark here plus minus sign when you remove the mod. So plus minus k plus 7 by 3 is equal to plus minus minus k plus 6. So find the value of k. K you will get k is equal to 11 by 6. Now therefore equation of line L, putting in equation of L, 3x plus 2y plus k is 11 by 6. So this is your required equation. So again listen here, there is a line L whose equation you can take as same as L1 and L2, only change the value of c. Why? Because L is parallel to both L1 and L2 having equidistance from both the lines. So equation of line L is 3x plus 2y plus k is equal to 0. Now for value of k, determine coordinate of any point from this line L by putting x0, y is minus k by 2. So here coordinate of point M lies on line L, M is 0 minus k by 2. Now from this point you have to draw the perpendicular distance from both the lines L1 and L2. Apply the distance formula, draw the distance from M on L1, that is D1. Then draw the distance from M on L2, that is D2. Then write D1 is equal to D2 and solving this relation find the value of k. Okay, then putting the value of k in equation of line L. Now see question number 22. A ray of light passing through the point, given point P12, you can take as P12 point, and it incidence at point A. A lies on the x-axis. Here x-axis you can assume as a mirror. So ray of light incident at point A. A lies on x-axis. So here coordinate of A you can take as x0. And a reflected rays passes through the point Q. Here this is the reflected rays passes through the point Q. Okay, Q, coordinate of Q is 5, 3. So from the normal, angle of incidence is equal to angle of refracted ray. You know, angle of incident ray is equal to angle of reflected ray. So here gradient of AP P12 AX0, gradient of AP is equal to with minus sign gradient of AQ. Why? Because here this angle, incidence angle or this angle will be same but opposite in sign. Because you are measuring here in positive direction and this for reflected rays you are measuring here in negative side, means clockwise, and this angle is anti-clockwise. Here write the gradient of AP is equal to minus, AP means line L is equal to minus sign gradient of line L1, that is AP. So gradient of AP by y2 minus y1 upon x2 minus x1, so 2 minus 0 upon 1 minus 0 is equal to minus gradient of AQ, same formula, y2 minus y1 means 3 minus 0 upon x2 minus x1, 5 minus. Solving it and find the value of x. So x is here 13 by 5. Therefore point A, which is on the x-axis, x0, so x is 13 by 5, y is 0. Okay.